Hey everybody, we are back. This is going to be video 2 out of 3 for the Winter 26 Unit 1 practice exam. Alright, so I'm going to go through the practice exam problems. You do have a key for this, but I'm going to walk through them. And these are all density calculations. Okay. Some things I will note. This lovely chart you see here is the exact chart that will appear on the exam. Use this as a reference. It will appear with each question you do. I think there are 3 or 4 density questions, where it wants you to calculate one variable or another using density, mass, and volume. So you'll get this little, chart popping up for every question that you come across, and it's going to look exactly the same. So we've seen it, we love it, we vibe with it. Another thing I will note is that the only thing that you're actually not provided with on the exam is the equation for density. So I told you this in class, I'll say it again. If there's one thing you want to memorize, it's your density equation. So we can review it. We know that density, D, equals M mass over V volume. Density equals mass over volume. Please memorize this. Please just, ingrain it in your brain. You will get a piece of scrap paper, so you could look at it right before going in, sit down, log into the test, write down on the piece of scrap paper, oh, density equals mass over volume. Awesome. So we have that, and now we want to try to go through and solve these 3 problems, okay? So starting with number 1. A sample of zinc metal weighs 13.4 grams. What is the volume of zinc? Now, this is not explicitly asking you for density. Note, it's asking you for volume. But if we go to our density equation, we do know that density equals mass over volume, so they all have to be related somehow. The goal of this would be that you're going to use the density table above and the given mass to calculate the volume. So don't let it trip you up if it doesn't explicitly say, oh, what is the density? So I'm just going to write down what I know I have based on the problem. So I know I'm given mass, which is 13.4 grams. Cool. I do not have the volume, so I'm just going to put a question mark. What is volume? And the last thing I'll need for this is density. So go up to the table, look for zinc. I see it here at the bottom. Zinc has a density of 7.1. And note that we have our, up here, grams per milliliter. Those are our units. So it's 7.1 grams per milliliter. Awesome. So I think first thing I will do is show you how to algebraically isolate for volume. You don't have to show any of this work. Again, this is a completely online exam. However, if you get stuck and you're like, oh, I can't remember what volume would equal, we're going to isolate it. So let's start. I know I have density equals mass over volume. My first step for isolation would be I need to get volume out of the denominator on the right side of the equal sign, okay? I do that by multiplying both sides by volume. So you can go O times by volume over here times by volume. And now my new equation is looking like, my new equation looks like density times volume equals mass. Now, I'm going to make a point that when we multiply by volume on this side, these are going to cancel out, okay? That's how we're getting rid of it. So the next part would be, well, I'm almost there. I now just have to move my density from the left side of the equal sign to the right side. I would do this by dividing both sides by density. Okay? Looky there. So when I divide by density on the left, I get rid of it completely. And my new equation becomes volume equals mass over density. I'm going to circle this in green. This is what we'll be using to solve this problem. So I'm just going to, plug everything in, put it into my calculator, and we should be good to go, right? So volume equals my mass, 13.4 grams, over my density, 7.1 grams per milliliter. And when I put this into my calculator, I pop out with a big long number, 1.88732 milliliters. Awesome. I will say this is a good answer. That is the answer. However, if, remember this is video 2 out of 3, we got to go back to video 1 out of 3 and note that we're talking about significant figures. So all of these answers should have proper significant figures. When we're doing multiplication or division, my number of sig figs should match the least number of sig figs I have in the numbers I started with. So let's count our sig figs up here. 13.4 has 3 sig figs, and 7.1 has 2, which means my answer can only have 2 significant figures. So I'm going to count that. I'm going to say, well, 1.88, all right, so 1, 2, that's it. This is my cutoff. So if I look to the right of my first 8 there, I have another 8. 8 is greater than 5, which means I will round up. And my final answer should be volume equals 1.9 milliliters. Wow, amazing. So again, multi steps in this problem to try to kind of isolate your variables, figure out what you're solving for, but overall, not too complicated. So let's go to the next one. A mystery metal weighs 122 grams and occupies 15.44 milliliters of space. What is the identity of the metal? So when they mean identity, they mean what is the name of it. You're going to have to pick, right, from multiple options here. It'll list things that are in our lovely density chart at the top. Could it be aluminum? Could it be copper? Could it be lead? Well, you don't know until you solve for density. So a problem like this would want you to solve for density, okay? So that's what we're going to do. Write down what you have. I know my mass is 122 grams, and it gives me a volume of 15.44 milliliters. I have no idea what my density is, but that will help me determine the identity of the metal. So, I have a density equation. Density equals mass over volume, and all you got to do is plug your numbers in. So density equals 122 grams over 15.44 milliliters. Fantastic. So, just put it in your calculator and you should pop out with an answer 7.90155. Fantastic. We can kind of already tell, based on our chart, what the identity of this metal could possibly be. However, I do want to note that we will be rounding, okay? I want you to round based on sig figs. It's good practice. So if you look at your sig figs in your original number, 122 has 3 sig figs and 15.44 has 4. So we're going to round to 3, okay? So 1, 2, 3. There's my cutoff. I do not need to round up. And my density will equal 7.90 grams per milliliter. If I go back up to my chart, okay, and I look here, what has a density of 7.90? Iron. All right? So you would say, oh, it's iron. That is the identity of the metal. Amazing. Okay, our last one. A little bit different. They're all different, right? So a sample of aluminum occupies 120 milliliters of space in a beaker. What is the mass of the aluminum? So I have, multiple things going on here. It's giving me a volume, 120 milliliters, and it wants me to find the mass. I have no idea what mass is. For this, I would need the density of the metal. Aluminum. So what is my density of aluminum? Let's go back up to the chart. Let's see right up here. It's the first one listed at the top. So aluminum is going to be 2.7 grams per milliliter. So I'll come down here and I'll write that. 2.7 grams per milliliter. Amaze. So I have everything I need. Now the question is, how do I solve for mass? Okay. So I have the standard equation, density equals mass over volume. Lovely, lovely. And again, kind of like the first one we did with these density problems, you can isolate these variables by multiplying and dividing things out. So to isolate mass, it's really just one step. I'm going to do the same thing I did in the first problem, and I'm going to get rid of volume on the right side of the equation. And I'm going to do that by multiplying both sides by volume. So now my equation would be density times volume equals mass. Yay! Or if it makes more sense to write it like this, you can say mass equals density times volume. These are both the same thing, but just written differently. So either one of these works. This is what we're going to use. Now we can just plug it in to the equation. Mass equals my density, 2.7 grams per milliliter, times 120 milliliters. All right, so plugging this into my calculator, I am popping out with mass equal to 324 grams. Oh, that's so ugly. 324 grams. Again, let's make sure we have the correct amount of sig figs. Looking at my two numbers, 2.7 has 2 sig figs, and 120 also has 2 sig figs, right? This trailing zero here, this trailing zero is not significant because there is no decimal point. So ideally, my answer will be rounded to 2 sig figs. So if I count 1, 2, there's my cutoff. So because the 4 is not 5 or greater, it means I'm not rounding up, and I will have to round down to 0 in place of that 4. So I'll keep my first 2 digits, and then the last digit will be a 0. 320 grams. Amazing! So these are 3 examples of density calculations that you will see on the exam. Please make sure that you know how to isolate your variables from the density equation, or just through pure memorization. Again, you don't have to show me any of this math, but it's important you know how to do it. So this is video 2 out of 3. Stay tuned. Watch the next video. We're moving on to our conversions, okay? Video 3 out of 3. Keep practicing, guys.